Mindsetters, welcome to today's Grade 11 Maths Show. Today we have a special revision lesson on Euclidean geometry. We have selected highlights from lessons shown earlier in the term to help you revise this term's work. So please post your comments and your questions on our Facebook page or on Twitter at LearnExtra so we can help you with your revision. You can also download the show notes for today's lesson from learn.mindset.co.za or click on the link on our Facebook page. Now it's time to get on with today's lesson.
Guys, we move on to the next one. Let's just indicate the angles that we've got. We've got 68 here and then 68 there as well that we worked out previously. Now, find the size of D1. We need to work out the size of D1. Right? Let's check where D1 is. There is D1. Right? And we've got AED. You've got your BEDC. Can you see that these points, guys, they are on the circumference? And you've got this angle here and this one here. So this is a cyclic quad. So BCDE is a cyclic quad. And we've got an angle outside. All right? So we conclude by saying D1 is also 68. It's equals to your B3, right? And we've got opposite angles of a cyclic quad. Okay, so you've got 68 there as well. Okay, right? Opposite angles of a cyclic quad. Now we move on to the next one. We need to work out what E2 is, okay? So E2, there is E2, right? Now, guys, please remember, you are in grade 11, but the info, your Euclidean geometry for grade 8 and 9 still applies here. If you look at this triangle here, you have that, right? This is EFD. It's not EFF. So you've got, this is 68 and then 20. And then this is a triangle. And you want to work out that angle, right? So now in grade 8, you talked of the exterior angle of a triangle. Now, so in other words, we conclude by saying E2, it's equals to 68 plus 20, which gives us 88, and our reason is exterior angle of a triangle, and our triangle in this case is EDF, triangle EDF, right? So now, next, we need to find C. Now, C is here, okay? Right, guys, and you can find it in different ways. We've got this as, this is 80, this is 88, okay? Now, if you look at this, this is your EDCB. It's a cyclic quad, right? And you know that opposite angles of a cyclic quad are supplementary. So what you can do is adding C to E, so you know that C plus E will give us 180 degrees, okay? So the sum of the two. So you've got C will be equals to 180 degrees minus 88, and then 180 minus 88, that's 92. So opposite angles of a cyclic quad, so that is 92. Or if you look at this triangle, this big triangle, you've got two angles, and you have one unknown, okay? So this is 68, there is 20, you're missing that. Now, to complete that triangle, you need to add 68 to 20 to the unknown equals 180 degrees. So we have 68 plus 20, which is 88, plus the unknown equals 180 degrees. Therefore, the unknown, which is C in this case, so C will be 92 degrees. Okay, so that answers our first question. It says in the diagram, M is the center of a circle. So we've got M there, all right, as our center, and diameter AB, right? So remember, for the diameter and the angle subtended by the diameter is 90. AC such that CDE is a tangent to a circle. So this is a tangent. So EDC is a tangent to the circle at D. ME is a chord and they intersect AD at F. MB is 2BC. Now, question number 1. If D4 is X, write down with reasons 2 other angles equals to X. All right? So we have D4, and this is X, right? Now, but we know that this is a tangent, okay? This is our tangent, okay? And we are told that this is a chord, okay? And if I continue with that, so I've got the angle between the tangent and the chord, that it is X, right? So the other angle that's going to be X is when I move this direction and then I get that angle there. So A will be equals to X. So angle A is X. You can say this is DAB is X, and your reasoning, it's tan chord theorem. Okay, right? So we've got the first angle that is equals to X. Now they needed 2. If we go to this circle, we know that AM is a radius and MD is a radius, and so it means that this and that, these two are equal. So AM will be equals to MD, which gives us an isosceles triangle. Now again, as I was saying, that your grade 8 geometry is also important. Now remember, with your isosceles triangles, we learned that the base angles are equal. So this will also be equals to X, all right? So D2 is also X, right? You can say base angles or isosceles triangle. AM, it's equals to MD. They both, it's a radius and a radius which is equal. Okay, right? Now, we move on to the next question. Let's just put in what we have. This is X, and then this is also X. Prove that CM is a tangent at M to the circle passing through MED. Right? We need to find MED. So this is M. Where is E? Oh, okay. There's E, and then there's D. So in other words, we want to show that here we can actually draw a circle, right? Now, one, I have to prove that CM, this is CM, we need to show that CM is a tangent to this circle, all right? Now, one, drawing that, that circle, I can see that some of you are just looking at this and saying, okay, there's 90 degrees there, and you've got a diameter, then there's that angle, which is 90 degrees, exterior angle of a cyclic quad as equals to the opposite interior, okay? But now we can also look at it this way, that we need to show that this angle there, this is angle between the tangent and the chord, so this will be our chord, should be equals to that angle, all right? Now, please be with me and shout if there's something you don't understand, all right? So now I need to work out this angle here, M1. but I can find M2, all right? M2 in the triangle, okay, you've got triangle A, M, D. There's a 90 degrees here, that's 90, plus that small angle, okay? So I can work out in that triangle, so I can have 90 degrees plus the unknown, which is your M2, okay? Let's just write M2. M2 plus X, okay, equals to 180 degrees, okay? So therefore, M2 is 90 degrees minus 2x. Okay, so we've worked out this, right? That is 90 degrees minus 2x. Now, that angle, because now these are angles on a straight line, all right? So it will be 90 plus 90 minus 2x plus the unknown, so we get 2x there, okay? So now, we need to work out this angle now, here, right? So we have, now remember, MD is a radius. EDC is a tangent. So in other words, we have a 90 degrees there. All right? So there is 90 degrees. There is also here, this is your 90 degrees minus 2x. Right? So now if you take that 90 degrees minus 2x plus the 90 plus this angle equals to 180 degrees, so that's some angles of a triangle, then we get 2x here, right? So that will be 2x equals to that outside angle. So you can conclude now by saying, therefore, CM is a tangent to the segment M passing through M, E, and D, because you've got an exterior angle of a cyclic quad equals to the interior opposite angle of a cyclic quad. Now, some of you have looked at it as there's a 90 here, and there's also a 90 there, subtended by the same, subtended by the diameter, which is good, or exterior angle of a cyclic quad equals to the opposite interior angle. Okay, right? Now, we need to prove that FMBD is a cyclic quad. Okay, let's just get what we have here. There's X, okay? There's also X, proven above, and this was your 2x, and previously we had 90 degrees minus 2x, okay? So now, what we need to work out is that FMBD is a cyclic quad. Now, we need to find F, there is F here, okay, FMBD, right? So, in other words, can we draw a circle around there? All right? Now, let's see. We've got this radius, okay, which is perpendicular to the tangent. So we know that this is 90 degrees, okay? And this here is 90 degrees minus 2x plus 2x, is that right? If we add these two, you've got 90 degrees minus, that's, okay, all right, guys. So the easier way is to look at it as this is your 90 degrees, and if you add the two, you get another 90, which is 180, and you've got AMB as your your diameter, which subtends that angle, which is 90 degrees. And then you conclude by saying MFDB is a cyclic quad. And why is this a cyclic quad? Okay? Because the opposite angles of a cyclic quad add up to 180 degrees. Because if you say M plus D, okay, this gives us 180 degrees. You've got a 90 degrees from the given information. Let's just look quickly here. You've got a 90 here. This is 90 degrees, okay? And this is AMB, which subtends this angle here, which is 90 degrees. So the opposite angles of a cyclic quad are supplementary. So that's the reason, okay? Right. Now, guys, we continue. Now, we need to prove that DC squared it's equals to 5BC squared. Okay, guys, they've given us, we need to show that when we're working with this, at the end of the day, we get DC squared being equals to 5BC squared. Now, we need to find that DC, and we need to find the BC, okay? So now, you've got BC there, right? There is BC, and then we have DC, okay? But now there is an information here. There is MB as twice BC. So now if you look at this triangle, all right, we know that MD is a radius and it's perpendicular to the tangent. So here we have a 90 degrees, all right? Now, what we can say here, we can use Pythagoras theorem here, and we know that MD squared plus DC squared equals to MC squared. Now, guys, at the end of the day, we want to make DC the subject of the formula, okay? So now, but I don't want MD in my equation, and I don't want MC in my equation. But there's something that I know, that MB is twice BC. So where I see MB, I can sub in to BC, all right? And at the moment, I don't have, but MB, it's equals to MD, right? I hope you all can see that from the center, okay, I'm drawing a line to the circumference. From the center, I'm doing a line to the circumference. So those two, there's a radius there, and there is also a radius MD, okay? So MD is the same as MB. So I can sub in straight away. This is MB squared plus the DC squared equals to, now, guys, MC, there is MC, okay? Now, to get MC, you need MB plus BC. So what we can say here is MC will be your MB plus BC. MB plus BC, but that is squared. Now, let's look at my final result. I need the DC and the BC, okay? Now, let's just look quickly. I've got the BC, I've got DC. Now, this I don't want, but it is given there that MB is 2BC. So I see MB, I can sub in with the 2BC. So this is 2BC, but that is all squared, plus DC squared equals to 2BC plus BC all squared, okay? Now, 2BC, but all squared, this gives us 4BC squared plus the DC squared equals to, now we have 2BC plus BC, that's 3BC squared, which gives us 4BC squared plus DC squared equals to, now the 3BC, by the 3BC, you get a 9BC squared, okay? So therefore, I will make DC squared the subject, so DC squared will be 9BC squared minus 4BC squared, which therefore gives us DC squared, it's equals to 5BC squared. And I've just shown all the steps, okay? And that was, we were asked to do, prove that DC squared equals to 5BC squared, worked it out with those triangles, and at the end of the day, you get your DC squared equals to 5BC squared. I hope you all following, okay? Right, now let's see if we've got another question on this part. Now, we have to prove that triangle DBC is similar to triangle DFM. Now, we have to indicate these two triangles. It's DBC, okay? So there is DBC, okay? And then DFM. So there is DFM. Right? So this is what we are required to prove. Required to prove that triangle DBC is similar to triangle DFM. If we can get at least two angles that are similar in two triangles, then we can conclude that those two triangles are similar. Okay? Right. So now what we have. Okay, before I move on, Quinn, are they still following?
We have a quick question from Umihlali, and he asks, how do we prove a quad is a parallelogram? But I think that is
we'll
a
just
job. Yes.
We'll get that one a bit
Alright.
later. Okay, right. Now, guys, what we did earlier on, we said this angle is equal to that, and this was also the same as that. Okay? Now, in triangle DBC, right? DBC, so this D, so D4 in DBC, D will be equals to your D on the other side, okay? Now, this is a triangle, F, let's just complete this triangle, FDM. Sorry, let's just get this out of the way. We're dealing with triangle DBC, so you've got D, and then you can put a B here, and then a C. Now on that other one, you've got FM. Okay. Now we need to find another angle, okay, that is the same. Okay. So you've got the 90 degrees minus 2x. We worked this one out earlier on, okay, and what else? We have this one is 2x, right? From previous questions. Let's remind me. And this one was 90, okay? So that, if this is 90, that is 2x. This will be your 90 degrees minus 2x, okay? Right, so you've got 90 degrees minus 2x here, and then a 90 degrees minus 2x as M2, okay? So on the DBC, we have C, okay? We've got C equals to, C will be equals to your M, okay? So your M, so this, completing this one, so it's BCD equals to FMD, right? And then the first one, it was, okay, this one was proven above, okay? And then, as well as that one, we worked it out. So now we can conclude by saying, okay, the other angle will be equal to that other one, okay? So therefore, you must just follow, you've got your DCB will be similar to triangle DMF, angle, 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 right? So these two triangles are similar. The last one, the last angles will be the same, right? And we conclude that this is angle, angle, angle. Okay.
Okay, guys, I hope you're enjoying this revision session. If you are struggling and need help, please post on the page or send your questions to the Learn Extra Help Desk. The links are on our Facebook page. But now it's time to take a very quick break. Don't go away. We'll be right back. Welcome back from the break, guys. Doing revision is really important, so I hope you are enjoying this lesson. I'd love to chat to you on our Facebook page or on Twitter, so please let us know how you are doing. Enough of the chat, now it's time to get back to some more revision.
In the diagram, AB is a diameter, right? You have to remember what the diameter is, okay, of a circle ABCD, and angle A2 is x, okay? All right? So you've got that. Okay, that's question 1. And I'm just checking because today we said Ndife is going to be giving us all the answers. All right? So Ndife, you ready, right?
Yes.
So you're working on the first question.
Yes,
okay,
I'm working.
Fine. You've got a diameter AB. Okay, so this is from A, and then there's going to be a center somewhere, and then there's a radius. Then there's up to B. That's your diameter. Now, this you need to remember. There's a theorem that we did also last week. That an angle subtended by a diameter is
equals to 90 degrees.
Thank you very much. So equals to 90. So this is the one that is subtended by your AB. Okay, so C2 will be 90. Now, they're asking us to find the size of D in terms of X. So we're looking for this, Ndife, right? Any
Yes.
idea?
I'm thinking we're going to consider the triangle DCA.
DCA. Okay, we've got the triangle DCA, all right? Okay, now, like what is just said, okay, we've got your AB as your diameter, and we know that the angle subtended by the diameter is right angle, so we've got a 90 there. Now, can you see that those points, the A, D, C, B, it is a cyclic quad. Okay, we
On the
drew
circumference.
a circle around those points, okay? Now, what you need to be reminded of is that opposite angles of a cyclic quad are supplementary, right?
Yes.
So if I add the
Then
D to the B, I have to get 180.
180, yes.
All right, so is it possible for us to get that angle?
Yes,
Okay?
it
Is-
is.
Yes?
Yes, it is possible.
How can I get that angle?
Because we know that A2 equals to X, and we know that C2 equals to 90. And
Yes.
then we have triangle ACB. Then we're going to say B, it equals to 180 minus 90 minus X.
Thank you very much, right there. Luni, yabo yasinathi?
Very clever.
Thank you very much.
Now
Aye,
you're good,
clever
yeah.
boy.
Really
All right, so you've
clever.
got the triangle ACB, okay? So he's saying you've got your B, okay, plus the 90 that we worked, that we know that AB is the diameter and it subtends that angle, plus the X, okay, equals to 180 degrees. So some angles of a triangle, right?
Yes.
Now we can make your B, we can make B the subject. So B will be 180 degrees minus 90. That gives us 90 minus X.
X.
So we have this angle here as 90 degrees minus X. Now we need to get D, all right? So now it is easy now for us because we know that this is a cyclic quad. Opposite angles of a cyclic quad are supplementary. So you've got your D, okay, plus the one that we just worked out, 90 minus X,
Equals
gives
to
us
180.
equals to 180, right?
Yes.
So therefore, D will be equals to what, Ndife?
My D is going to be equals to 90 minus X.
Come again, just double check that. You've got a 90 minus X here on your left.
It's going to be, we're going to take those to the other side. It's
Yeah.
going to be 90 plus
It's
X.
90 plus X. So this is 90 degrees plus X.
X.
So your D is 90 degrees plus X. Okay, so thank you very much, Ndife, on that question. All right, I hope it answers your questions, guys. Right, now we're moving on to question 2. Right, sorry, with question 2, it says, O is the center of the circle, okay? So you've got O there as the circle, as the center. And then AE, it's equals to EF, right? Now we need to find where AE is. Okay, so AE,
Is equals to,
right, will be equals to EF. Okay, so we indicate that by that. Okay, are we together?
yes.
All right, and BAF and CF are straight lines, okay? and C1 is x. Okay, now, so they've given us C1. C1 is x, okay? We need to express, the first question, we need to express E1 in terms of x. Now, guys, there is E1 here. How can I get E1 in terms of x?
My idea can be to first find f, angle at f, which is
Okay.
going to be equals to x also. Because
Thank you very
tan
much.
theorem.
Why is it this angle here equals to that?
Tan chord theorem.
It's tan chord theorem. So we've got this angle is x. Guys, are you all watching? You've got a tangent, okay? Right. So BC, let's just go back. BC is a tangent, okay? So we know that BC is a tangent. We know that AC is a chord, all right? So it will be equals to that angle there. So we've got x. We're not there yet. We need to find E1, all right? But now there is something that they've given us. We know that AE, it's equals to EF. So you've got an isosceles triangle there.
Yes.
Is that right?
Yes.
So in other words, we have this whole angle here as x. The base
These
angle
angles
is
of
equal. Okay?
emphasis, yes.
Sure. So now we've got F is x and A is also x. Now, how can we find that E1 now?
We can consider triangle AEF,
Consider triangle AEF.
and we know two angles, base angles with equals to x, so we can find the other angle at E
Okay.
on the straight line with, the angle AEF.
Okay. Now, guys, Ndife is saying, okay, you've got that triangle, all right? So this is triangle AEF. He's completing the triangle, work out what this angle is. Okay, that's another option.
Yes.
You get that angle as 180 degrees minus
Minus
2x, right? If you add all those angles. And then the next part that he's going to do is to get that angle by saying E1 plus that one, 180 minus 2x, which gives us 2x.
Yes.
So he's got this one as 2x, okay? But the other way of looking at it is that this angle is an exterior angle of this triangle. So if you add the two, the x and the x, so therefore E1 is E1, it's equals to 2x. So whichever way you look at it, at the end of the day, you'll get the same thing. All right, guys, I'm just going to give you 2.2, right? Okay? I don't know if you can go.
You can.
Just finish this
Okay.
one. All right. So now the next part, they're asking you to express O1 in terms of x, right? O1, okay, there is O1 here. We need to express O1 in terms of x. Guys, we need to open our eyes. Ndife, please help us.
Yes. Now, because that is the angle at center, and we know the angle at the circumference subtended by the same chord. So O1 is going to be twice the angle at the circumference subtended by the same chord.
Thank you very much. Remember that theorem, guys. You've got an angle at the center, all right? So it's subtended by AC, okay? And AC, again, subtends that angle there at the top there, which is your F. So we know that O1 is twice F, all right? Angle at the center is twice the angle of the circumference. So, and 2 by
X.
x, so we know that f is x, so therefore O1 is 2x, all right? So now that's done. And then 2.3, now they're asking us why is OACE a cyclic quadrilateral, right? Why is AOEC a cyclic quadrilateral? Why is it that we can draw a circle around those points? Okay?
Yeah, I think it's going to be because we found that angle O1 equals to 2x and E1 equals to 2x.
Thank you very much. That's correct. Right. O1 is 2x and O2, E1 is 2x. So they both subtended by AC. So therefore, it can be a cyclic quad. Okay.
Now it's time for a break, so don't go away. We'll be right back. Welcome back, Mindsetters. Even though we are selecting highlights from previous shows, you can still follow me on Twitter @LearnExtra, or you can post or comment on our Facebook page. Now, let's do some more revision.
In the sketch below, you've got P, Q, R, and S are the points on a circle. So you've got your P, Q, R, and S points on a circle. And MRT is a tangent at R. So you've got MRT as a tangent there. And your S2, it's equals to 65. So S2 is 65. And your R3 is 35. So you've got R3 there. Now you need to find, with reasons, the sizes of. First of all, you need to work out what R1 is. In our diagram, you've got R1 here, and you are told that this is a tangent, okay? And then you've got a chord there, right? So the angle between the chord, can you see that this line goes there? So this angle here, R1, will be equals to your S2. So R1 equals to S2, all right? And this is your tan chord theorem. But we know that S2 is 65 degrees. So therefore, your R1 is 65 degrees. So you've got your R1 and also your reason there. Okay? Right. So we've got 65 there. Now, R4, we need to check where R4 is. All right. If we look at our rider here, there is R4 here. All right. And you've got a tangent MRT. And number 2, you are told that PR is a diameter. So you've got PR, okay? This is going to pass through a center. So you've got a radius there that will always be perpendicular to your tangent. So in other words here, we know that, okay, your R4 plus R3, okay, these two angles, they add up to 90 degrees. And why is that? Because you've got the radius, okay, there's a diameter which is perpendicular to the tangent. So you can here conclude by saying PR, you can say diameter PR is perpendicular to a tangent, and you've got the tangent there, all right? But now there is something that they told us. We are told that R3 is 35. So you've got R4 plus 35 equals to 90 degrees. And therefore, your R4 will be 90 degrees minus 35 degrees. And then you simplify that, 90 minus 35, you get 55. Okay, so R4 equals to 55. Right? Now, we need to work out what S3 is. Okay? So there is S3. Right? We have a 65 there, and it's not going to help us. Okay? Now, if we look at our tangent, you've got MRT. All right? You've got your diameter. And now, if you look at your theorems, guys, you must always remember your 9 theorems in grade 11. There's a radius, your diameter, and an angle subtended by a diameter is right angled. So we know that this is 90 degrees. Okay, the whole angle there is 90 degrees. But that angle S, the whole S, plus S3, so you've got that angle, that 90 degrees, so we have 90 degrees plus S3 equals to 180 degrees, because we can see here clearly that these angles lie on a straight line. If you check from here to there, we know that this is 90, okay? So those two angles, they lie on a straight line. So therefore, S3 equals to 180 degrees minus 90, which gives us 90 degrees. So here, our reason is angles on a straight line. Okay, right? So that's done with your question 1, right? If we move on to the second question, the first is needs to remind us of the theorem. Complete the theorem. Angles subtended by the chord at the center on the same side of the chord are, okay? So you've got, okay, let's just make an example here. There is a chord, okay? Right, so these two angles will be equal. So those two angles are equal. Okay, that's your first question. Right, now moving on to the second part of question 2. In the sketch below, AD is parallel to BC. Okay, so we've got BC and AD. Those two guys are parallel. A, B, C, D, and E are points on the circumference of a circle. EB, EC, and BD are straight lines. And EF, it's equals to EG, right? So now it's already given here that EF, it's equals to EG. And the other thing that we know is that that is an isosceles triangle. So it means that our base angles will be equal. Okay. Right. Now we need to prove that B2 equals to D2. Okay. Or show that B2 equals to D2, or why is B2 equals to D2. All right. So now if we look at your BC and AD, and you've got your B2 here, and there is D2 there, all right? Now, we look at our lines. This line is parallel to that line, and this forms an N shape, remember in grade 8. So this will be equals to that. So B2 will be equals to D2. There's the alternate angles, right? Because you've got those two lines that are parallel. So BC is parallel to AD. Okay, that is your 1 mark, right? And we need to prove that E1 is equals to E3. We can work it out here. So E1 equals to E3. We are required to prove that. Okay, now we need to go back to our diagram. All right. Where is E1? We have E1 here, and we've got E3 there. All right. So now, if we look at this, from your chord DC, it subtends that angle, right? Subtends E1, and it also subtends B2. So what we can say here is that E1 equals to B2, subtended by the same chord there, all right? And then the other thing that we know is that this E3, okay, E3 is subtended by AB, and it's also equals to your D2, all right? E3, it's equals to, now let's look at that. You've got your AB subtends E3 and also D2, all right? So it's equals to D2, all right, subtended by the same chord. But if you look at our answer here, the first part, we said we have proved that B2 equals to D2, all right? So in other words, if B2 is equals to D2, all right, proven above, so it means that E1 is equals to D2 and E3 equals to D2. So therefore, we conclude by saying E1 is now equals to your E3, both equals to D2. All right. So it answers our 2.2.2. Right? Now we move on to the next question. We need to prove that triangle AEF is similar to triangle CED. Now, guys, it is very wise to actually use colors in your riders. So let's see where your AEF is. So there is A, E, F, okay, and your CED, C, no man, CED. So you're dealing with those two triangles, right? Now let's mention things that are common. In the previous question, we've proved that your E3, it's equals to E1, all right? So in your AEF, those E3 will be equals to your E1. And one other thing, guys, if you look at this, right? That angle there at the top subtended by ED, okay? This angle will be equals to that angle there, which is your C1, right? So we can start working from there. So you've got your A. So angle A, it's equals to angle C, right? Both subtended by ED. Okay? Right? And the next thing is, we know that E3, it's equals to E1, right? Proven above. Right? So you've got your AE, then the remaining one will be your F, and then here CED, that completes that triangle, right? So this is your remaining angle, or you can just work it out if you let one be X and so forth and so forth. So therefore, triangle AEF is similar to triangle. The way you were naming them when you're working them out is similar to triangle CED. Okay. Now, guys, the last question in question 2 for 2.2.4, you need to prove that FBCG is a cyclic quad. Okay? So now, if you come back here, FBCG. Okay? So we want to prove that you can draw a circle around those points there. Okay? So now, but the first thing that they told us earlier is that EFG is an isosceles triangle. Okay? And one thing that we understand and know is that this angle here, if this is X, then that angle is also X. Okay? And another thing, guys, we were told that BC is parallel to your AD. Now, it's very important to remember your geometry, your grade 8 and 9 geometry. Because if you look at those two parallel lines, if this is X, then the whole angle there is also X. Okay? If this, can you see that it forms an F shape, right? If this is X, this one is also X. All right? Now, can we work out this angle? Yes, because you've got your X here, and then this, so F2 plus X will be equals to 180 degrees angles on a straight line if we let that F3 equals to X. So therefore, F2 is 180 degrees minus X. So this angle here is 180 degrees minus X. And now we have said that this is also X and that is X. If you look at the F2 and the C2, right? if you add the 2, if you say F2 plus C2, this it's equals to 180 degrees minus x, okay, which is your F2, and then your C2 is x, right? So therefore this equals to 180 degrees. Now, can you see that the opposite angles of a cyclic quad gives us 180 degrees, which is one of our theorems. So we conclude by saying, therefore, FBCG is a cyclic quad. Opposite angles of a cyclic quad are supplementary.
We've come to the end of today's show. Thanks for joining me and for chatting to me during the show. Please visit our website, learn.mindset.co.za, to get the notes and to watch the videos from earlier in the year. And remember, we are here to get you through the year, so stay connected. Goodbye.